Good evening, doctors. Today we are going to talk about the basic cellular physiology as one of the important topic as far as the FRCEM primary examination is concerned. So there are so many things that is covered under the umbrella of the basic cellular physiology. You need to know about the homeostasis. What is homeostasis? Second thing, how it is maintained. Homeostasis maintained through the negative feedback mechanism. It is maintained through the positive feedback mechanism. Then you need to know about the intracellular compartment, extracellular compartment, what is the constituents of the extracellular compartment and intercellular compartment. Plus you need to know about the osmolarity and osmolarity. What is the difference between the osmolarity and the osmolarity? And should know the tonicity. Should be the isotonicity. You should know the hypertonicity and the hypotonicity. So these are the few terms that we are going to learn this in this lecture, this particular lecture. As far as homeostasis, we'll start with the homeostasis first. So all of us know what is homeostasis. So if you go back to this thing, definition of the homeostasis, it is nothing but is the ability of a physiological system to maintain conditions within the body in a relatively constant state of the equilibrium. So what is homeostasis? All of us know, so we might have studied in the 9th and the 10th standard as well. It's nothing but it's the ability of a physiological system to maintain conditions within the body in a relatively constant state of the equilibrium. It's a Latin word as such. What does it mean? It means status quo. Means whatever the condition is there, continue to maintain that condition. No need to change. What does it mean? In other words, if you want to remain in a physiology, you should have the homeostasis within. That's what the homeostasis is mean all about. If there is a change in the homeostasis, so definitely the physiology will convert into the pathology and you will have the disease. That's what it means. Homeostasis means. So the homeostasis, each cell in the body benefits from the homeostasis. So each cell in the body, it's get benefited from the state of the homeostasis. At the same time, every cell contribute to the homeostasis, to maintain the homeostasis. So it's like a symbiosis. Every cell has to contribute some other thing to maintain the homeostasis, and at the same time, every cell will get the benefit of the homeostasis. I'll give an example of homeostasis to you. You are a very efficient physician and you know how to work in crowded department. You know how to work in ICU and ward and everything. You know it very well. You are willing to work as well. You know how to work. You are willing to work, but as the environment inside of the hall or inside the ward is not maintained. It's very hot. There is no AC, no fan is there, and you are sweating there. So will you give your 100% in such environment where there is a hotness is there inside and you are sweating? You cannot sustain such a hot environment. So is it possible for you to give your 100%? No, not at all. The same is homeostasis. It's a status quo condition in your body. For every cell it needed to have the status quo. So physiological condition to work and efficiently. Okay. So as we said, every cell is required to contribute some other thing to maintain the homeostasis. How they contribute? So there is established mechanism. There are established mechanism by which you got this homeostasis is maintained. So you got a negative feedback mechanism. One is regulatory mechanism is regulation of physiological variable is by the negative feedback mechanism. One more is there, that is a positive feedback mechanism. So first, talking about the negative feedback mechanism. So what is that? Actually, negative feedback mechanism comprises a system. It's a complete system. And it is having the component of detectors are there is the comparators and effectors, right? So detectors are there. So if something abnormal is going on, for example, there is an increase in the temperature of the body. So this is what the variation happen. Somebody has to detect it. Some cell has to detect it. That's what called as detectors. So in this scenario, say for example, it's a nervous system, sensory nervous. They are the one who act as a detector if there is a rise in the temperature of the body. this sensory information will be taken towards the central system, towards the hypothalamus. And then hypothalamus, there will be the control. We know, everybody, all of us know, there is a hypothalamus, there are the center for, thermal regulation center is there. We know, all of us. So once this information reaches to the hypothalamus, thermal regulatory center, it gives the instruction. It gives, there is, comparator is there. That's what the control system is having, the comparator. Oh really? There is increase in the temperature? Is it so? Or somebody is coming from the outside. Outside maybe the hot temperature is there. So let him settle down. Then only it will give an instruction. That's what the comparator is there. So comparator is there, and then this comparator will give information or instruction to the end organ. That's what the effector. So in this scenario, for example, it will be a sweat gland all over the body, and it will give an instruction to the sweat gland. Sweat gland will start sweating, and automatically temperature will come down. This is what the negative feedback mechanism. Say for example, one hormone is there, you got blood sugar, you got any thyroid hormone is there. For example, thyroid hormone, you got thyroid stimulating hormone is coming from the central nervous system. Where does it coming from? Thyroid stimulating hormone, all of us knows it's coming from the anterior pituitary. It's coming from pituitary gland, thyroid stimulating hormone. It's coming from there. So if there is a thyroid hormone is in excess, for example, T3, T4s are more, so there will be less increase in the less secretion of the TSH. TSH will not will come from the pituitary gland, because already there is a T3, T4 are on rise, so it will not come there. So that's what it is. So if there is a less T3, T4, TSH will be increased. The secretion of the TSH will be increased. The TSH will come and it will stimulate the thyroid hormone to secrete the more and more T3, T4. That's what we know. This is what happened in the physiology. If something goes wrong, if there is no TSH is coming, so there is a pathology then. It's not a physiology. We are talking all these things within the physiological limit. So understood? That's what the negative feedback mechanism. I think you got it, right? So, but this required a mechanism. So there is one more, I'm sorry. There is one more mechanism is there, as we said earlier. Apart from the negative feedback mechanism, you got a positive feedback mechanism also there. So how does it different from the negative feedback mechanism? How does the positive feedback mechanism differ from the negative feedback mechanism? In case of the positive feedback mechanism, you need to cause a rapid amplification to a maximum response or an endpoint, right? And that is acts like a switch. So whatever information is coming initially, it has to amplify. For example, in case of labor, if you got oxytocin release, that oxytocin will come, that's the end organ, is uterine muscles. It will go to the uterine muscle. It will cause the contraction of the uterine muscle, oxytocin. Once it cause the contraction, it will further increase the release of the oxytocin. That will amplify. It will amplify. We talk about the homeostasis. And initially only we said why you need the homeostasis. Because every cell, it need a status quo and physiological environment to work efficiently. So normal functioning of the protein is essential for the life and usually requires binding of protein to other molecules, right? So we need normal functioning of proteins in our body, and it's essential for life, and usually that protein requires binding of protein to other molecules, right? The shape of the protein is essential for the binding to occur, and small changes in the environment surrounding protein can modify the shape of the protein. Homeostatic mechanism prevents such changes from arising in normal circumstances. That's what the most important thing or most important aspect of the homeostasis. So there are proteins in our body, and these proteins need to bind other proteins to have the normal functioning of the body. So if a minor change in the shape of the protein will not allow that binding, and it will cause the disfiguration of the protein, it will cause the denaturation of the protein, and the normal physiology will be hampered. So the surrounding environment, that's what the homeostasis. It should be productive one. It should be status quo. It should not maintain. So that's what we know about it, right? So up till now, what do we learn? We learn about the homeostasis, negative feedback mechanism, and the positive feedback mechanism, and why you need the homeostasis. We need it to have the normal protein functioning, right? So do you have any question up till now? If you have any question, just let me know. You can tag me on the Facebook. You can tweet me on my Twitter account, on Instagram account, as well as you can WhatsApp me. So thank you very much for watching it, and see you for the next lecture tomorrow morning. Thank you.